Thacker. And this is a 555 timer chip project using a diode. So pinning out my timer chip at pin 1 underneath shoots to negative. Pin 2 is my trigger, and I have pin 2 going to negative through a 1000 microfarad capacitor. Pin 3 is my output, and pin 3 is going to a resistor. That's a 330 ohm resistor in a green LED. That is my workload, my output. Pin 4 is pin 4 feeds back into my positive bus. I have it connected to pin 8 up here. Pin 5 is my control voltage, and I really don't need it, but I wanted to go ahead and get that connected anyway with this. This is a 3 picofarad ceramic capacitor, and that's going from pin 5 to my positive bus. Pin 6 is
the threshold.
Discharge. And pin 6 is connected to pin 7 with a 1K ohm resistor. Pin 7 is my
discharge.
Threshold. My threshold is connected to pin 8. Pin 7 to pin 8 with a 330 ohm resistor. So that's what gives me that the threshold is, it's almost a third versus 2/3. But what's happening is, instead of getting like 2 seconds on and then 1 second off, I have a diode in the circuit. And what the diode does is it kind of smooths out that oscillation. And now, instead of it being uneven, it's probably about 50%. I'm gonna try to work out the math here after I show what's going on here. And then I almost forgot, but pin 8 shoots to the positive bus. As you can see, I did most of my soldering on the back. I made my circuit. What I do is I take the wires that I cut from resistors or capacitors earlier in the project when I was still trying to figure everything out and get it working. So I had a lot of little wires left over from that, and I would use those to make my connections all the way across the board. I really took my time, tried to really get a lot of practice and experience using the soldering iron. It's a whole lot better than my first attempts at this. Let me see if I can find. As you can see on this board, the soldering is much more crude. I burn up a lot more stuff. But this one here, I took a whole lot more time and care to make sure that my connections were smooth, that I wasn't getting so many hot welds. That's just a little extra bit that I left on there. I'll clean that up later. But I think my soldering has improved quite a bit on this project. That's a wire. Just one thin coating of solder. So this is a circuit using the 555 timer in astable mode. And the astable mode is the most common mode that you'll find with 555 timers. And what it means is that I can create a repeatable action using the timer and the components. So in this mode, the output pin cycles from high to low continuously. Both the threshold pin and the trigger are connected to the 1000 microfarad capacitor. When the circuit first receives power, the voltage is low at the capacitor, the threshold pin, and the trigger pin. And then if the trigger pin voltage is low, the output is high. And when the output is high, then the discharge pin is in its off state, and the current's able to flow through the resistors and charge the electrolytic capacitor. Now, usually in this circuit without the diode, the capacitor's charge will reach 2/3 of VCC, and then the output pin will be deactivated. When the output pin is low, the discharge pin will switch on, causing the capacitor to drain the ground. Once the capacitor voltage drops to 1/3 of VCC, the trigger pin disables the discharge pin and the capacitor starts charging again. But since I use a diode in this project on R2, what the diode does is it usually just kind of cancels out R2, and then it instead of having 2/3 on and then 1/3 off, the light will just keep blinking in the pattern set by R1. So it'll be on and off, then on, then off. And a really cool thing about this is there are formulas that we can use to check the timing of it. And then we could just plug in the different amounts of the capacitors or the resistors and find out how much time that we can get the light to blink on and then to blink off. Make sure that